Yes, class. Am I audible to all of you?
Yes, ma'am.
Taha, Sufyan. Okay, good. So it started with capacitance. What was capacitance? Capacitance basically meant that the ability to store charges. So if an object is able to store charges, we'll call it as a capacitor. And this method by which the charges store, or this property of the charges, or the ability of the object or the body to store the charges, it is called as the capacitance. So capacitance is the ability, capacitor is the device. This is what we've studied. And one ratio also we had studied, that capacitance is charge divided by potential. Now, one thing we didn't discuss, what is the capacitance of a conducting sphere. So if you have a conducting sphere, there's a different formula for it. See, if you are having a conducting sphere, so basically for a conducting sphere, you should know what is the potential of a sphere. So the potential of a sphere is kq by r. So this is kq divided by r. Okay. I want to write down the full formula of k, which is 1 over 4 pi epsilon naught r. So this is q over 4 pi epsilon naught r. Okay. So this is q by 4 pi epsilon naught r. V is equal to kq by r. Next is the formula of capacitance, q by v. So let us put the value of v here from this. So C will be equal to q by, what is potential q? And this term will go in the numerator, 4 pi epsilon naught r. Q cancelled, C is equal to 4 pi epsilon naught r. This is the formula of capacitance. It's just that this is for a. Suppose the dielectric medium is present. So that we have studied, K is equal to E. We have studied that E, that is epsilon naught. So if this is the case for a medium, what we'll do? This will be written as C dash 4 pi K epsilon naught R. Okay, this is for a medium. So if you have a medium, you have to multiply it with K. What is K? K is a dielectric constant which acts as an insulator. Now, one thing class, if the formula of C is 4 pi epsilon naught R, suppose I consider Earth as a sphere, as a conducting sphere. So if I put the formula of radius as 6.4 into 10 to the power 6 meters, okay, and then epsilon naught is there, pi is there, 4 is there. So let me, if I'm considering Earth as a complete sphere, it means radius of Earth has to be put. So if you put radius of Earth, when you put all the formulas, C is equal to 4 pi 3.14 epsilon naught 8.85 into 10 to the power minus 12 r 6.4 into, I'm not audible. Am I not audible, class?
Good.
Okay, now is it better? Now tell me, I've changed the internet. Now is it better?
Yes.
Okay, okay. Please update me again, Sufyan and Ta, both of you, if my voice lags. So if you put the value 4 pi epsilon naught and radius of Earth, I am saying that if we say that Earth is a conducting sphere, okay, C is equal to 4 pi epsilon naught r is the formula that we have studied. If I say Earth acts as a conducting sphere, so 4 pi epsilon naught r, we'll put this value. You will get 711 into 10 to the power minus 6, or you can say 711 microfarad. This is the formula. This is the value which you will get. So you have to remember this. Okay, 711 microfarad. Write it till here. Okay, now the next thing that we are talking about the capacitor is how to construct a capacitor. So construction of capacitor is very easy. Just take two conductors and in between them there should be an insulated space present, insulated area present. So look, suppose of any shape. Suppose I have taken two conductors of opposite charges and in between them there has to be an insulated space present. This is insulated. This one is positive, this one is negative. That's how we construct a capacitor. So this and this, these are conductors. Okay. Now see, device used to store charge is called a capacitor. Like the flashlight of mobile phones, all the energy goes because of the capacitor present into the mobile phone. And when you charge it, it recharges itself. So requirements, two conductors having opposite charges, dielectric medium present between them. Now there are three types of capacitors present. What is meant by a parallel plate capacitor? See, parallel plate capacitor basically means square flat plates are taken, rectangular flat plates are taken and they are kept like this. And this is how the capacitor is constructed. If these plates are in the form of sphere, then we say this is a spherical capacitor. If these are cylindrical, then it's a cylindrical capacitor. So these are the three types of capacitors. Now one thing class, in your syllabus, you have to do parallel plate capacitors in detail and in very much depth and it will be asked in the exam. Spherical capacitor, we'll just see the formula of it, and cylindrical capacitors you don't have to do at this level. For your entrances, you have to look at it, but for the board exams, do not have a look at this cylindrical capacitor. Now, what is the principle of a capacitor? This also I'll tell you, then I'll give you time to copy down. What is meant by the principle of a capacitor? Now, basically principle of a capacitor means C is inversely proportional to V, that you can see. So if potential decreases more, capacitance will increase more. By whichever amount the capacitance, the voltage was increasing. Now it will increase more due to, because it is getting down, so capacitance will now increase more. This is what is meant by principle of a capacitor. That capacitance can be increased if you bring an uncharged earthed conductor near it. Means, see, suppose I have this. This is positively charged. What I'll do, first thing that I should do is, I should put them on an insulating stand. This is an insulating stand. So positive charges, this is negatively charged. Okay. Now, if I earth it, earthing occurs. So all the charges will go zero and this will have zero potential. So what will happen if this has zero potential, potential has decreased, so capacitance increases. This is what is meant by the principle of capacitance. Write all of this, then I'll discuss some more things. See, now when we are starting with the parallel plate capacitor. So first case is if two plates are present and in between them the air is filling both the plates. So you have the surface charge density as sigma, charge on each plate is Q, area is A, D is the separation between the plates. Now, electric field due to this is sigma by 2 epsilon naught. Electric field due to the second one is sigma by 2 epsilon naught. So when you add all of them, total electric field is sigma by epsilon naught. Now, sigma is what? Sigma is charge divided by area. So let's put this. So electric field will be equal to charge, epsilon naught and area. Now there was one more relation of electric field with the potential, which was the gradient. That electric field is a product or is directly proportional to the potential gradient. So E is equal to V by D. So what is the potential? V, or if we are just calculating the potential, let us first just calculate the potential. Potential will be E into B. Now let's put the value of E here. What is E equal to here? E here is given as Q by epsilon naught A. So this becomes Q by epsilon naught A and this is the D present. Now potential we require capacitance. Capacitance is charge by potential. So let's put the value of potential here. So charge divided by, what's the potential? Q. Then what will go up? No, QD will come down and epsilon naught A will go up. That's it. That's the formula of capacitance in air when two plates are filled with air between them. Epsilon naught A by D. This is the formula. What is C? C is the capacitance. What is A? A is the area. D is the separation. Okay. Now, if the second case is if dielectric was filled, then it's very easy. K is equal C epsilon naught. C dash will be K epsilon naught A by D. That's it. So two cases will be done like this. These derivations also come in the exam. Right? Start writing from here. Okay, the next one is parallel plate capacitor. If a dielectric slab is put, and see that slab is not completely covering both the plates, means of partial thickness a slab has been inserted. So the thickness of the slab is T and the distance between both the plates is small t. Now air is filled apart from the dielectric slab. Okay. Now you have two electric fields now. One is the electric field between this surface, which is the electric field of air, E naught, sigma by epsilon naught, and one is the electric field of the dielectric slab. That is this ED. So ED is sigma by K epsilon naught. You'll multiply it with K. Why? Because this is a dielectric material, and whenever you have a dielectric material, you multiply it with K. So what will be the total electric field? Sigma by epsilon naught plus sigma by K epsilon naught, right? Now, potential will again be distance into electric field. So let's put the value. ED is what? ED means dielectric. So it means sigma, or why to put sigma? Let's put directly Q by A. Let's put directly Q by A. So Q by A. So this is sigma by K epsilon naught T. Right? Sigma by K epsilon naught T plus electric field due to the air. This is just simply sigma by epsilon naught and no K over here. So D minus T. Now capacitance is charged by potential. So charge by potential. So once you write charge by, entire term will come. It's just that from here, if you take Q by A epsilon naught common, you will be left with T by K plus T minus T, right? This is also minus. This is not plus. So that's why only minus is left. So once you divide these two, Q will be cancelled. A epsilon naught will go up. So final answer is A epsilon naught sigma A epsilon naught by D minus T plus T by K. It's a huge, little lengthy formula. So you have to remember this. You have no option. This formula has to be remembered and the derivation can also come. What is C? C is the capacitance. What is A? A is the area. Epsilon naught, this is 8.85 into 10 to the power minus 12. D, D is the distance between the plates. What is T? T is the thickness of the slab. Thickness of the slab. And what is K? K is the dielectric constant. So this is the formula, and this is the entire meaning. These are the meanings of the symbols which are present. Write down the second derivation too. See, parallel plate capacitor, if this instead of this dielectric slab, if it is filled with electric field, what will be the difference? The difference is that electric field inside the conductor is zero. So in our this derivation, we'll get this term as zero. Only we'll be having electric field is what? Q by A epsilon naught, right? Sigma by epsilon naught is electric field. D minus T. That's it. This is the only formula that we have. Now see, once you write capacitance is charged by potential, so capacitance will be charged by potential. Potential is Q, D minus T. A by epsilon naught will go up, Q cancel. So what's the formula? Formula is A epsilon naught D minus T. This is the formula of capacitance. So what are the four formulas we've studied? First is completely filled with air is epsilon naught A by D. C is equal to K epsilon naught A by D for completely filled dielectric. C is equal to epsilon naught A by D minus T plus T by K for partially filled. And C is equal to epsilon naught A by D minus T is partially filled conductor. Write down this two. So all the four derivations of parallel plate capacitors are over. Write it.